Good evening to all. Can you please anyone confirm that my screen is visible and my voice is audible?
Audible, sir.
Okay, thank you so much. Okay, let us start the session. Okay, today we are going to go for the week 4 assignment discussions. Okay, so in this last week, actually, I think you have covered the session. Okay, like what is stability and how RH criterion, what is you have to do the stability analysis by using RH criterion. Okay, then how the poles and zeros decide the stability of the system. Then you can decide the stability from the transfer function method. Also, which type of stability you want to be more focused, whether closed loop system stability, open loop system stability. Then relative stability. All these things will touch some of the questions related to all these topics. Okay. So first of all, just a definition I just want to give here, that what do you mean by stability of the system. Okay, how many types of stability are there? Okay, so generally actually stability means you can say that a system will be stable. Okay, how a system can be stable? Okay, so what is the definition of stable in control system? So if you have given an input, let's say I'm giving an input. Okay, and that input is bounded system. Okay, bounded means it has a finite value. Okay, you can say that u of t is a bounded signal. Okay, because it has a fixed amplitude from 1 to infinity. Okay, but you can say that ramp signal is a unbounded signal because its magnitude at t equal to infinity is infinity. It is an unbounded signal. So delta of t is an also unbounded system. Okay, so you have to take a bounded input. Okay, if your input is bounded and you get an output corresponding to the input that is also a bounded signal, then the system will be stable. Okay, so means basically you can say that for a uh, input bounded system which gives you output also bounded system, then that can be defined the stability of the system. There is another type of stability is called marginal stability. Okay, what do you mean by marginal stability? Marginal stability means it is at the verge of stability. Okay, if you go beyond this point, then you have landed into a unstable region. So what is the definition? How you have to solve? Whatever the definition I am saying, these are the methods you can go and implement to solve the questions. Okay, so we have to check the stability of the system. Always you have to deal with the input bounded system. You cannot give a random signal and check the output. Okay, so you have to take a input bounded system. Similarly, for the marginal stable definition is that suppose I am given an input bounded. Okay, I am giving an input signal which is bounded, but what will happen to the output? The output always maintains a constant amplitude and frequency of oscillation. It means you can say that whatever the output you'll get, it has a fixed amplitude, but it has a constant frequency of oscillation, like a sine wave. Sine wave having a fixed amplitude of 1 to -1, but it is oscillating at a frequency of natural frequency, depend upon which frequency. Line frequency is 50 hertz. Okay, so in a switching frequency you can count 100 kilohertz. Okay, so you have to switch. It doesn't matter at what frequency it will oscillate, but it has to oscillate at a particular frequency of oscillation. So in that case, what you call, if you give a input signal bounded, but you will get output which is of this type, having a constant amplitude, but it has to be a damped oscillation. Okay, then it is called a marginal stable system. Okay, let me solve some question based on that. Okay, so how to solve the stability question? The stability type of question you can solve by using the root Harris criterion. Okay, that is called the most favorite actually Harris criterion. Okay, so I'll tell you that how can you apply this RH criterion and how the RH criterion is a powerful tool. By looking at the question, I can see that whether the system is stable or not using few calculation on one side of the paper. Okay, don't do a multiple calculations. Don't do to find out all the constant coefficient everything. So let me move to the next slide. I'll show some questions. Okay, questions. Okay, let me give in questions. Okay. I'm just giving a simple question. Let's say a square plus 25 equal to 0. I'm giving this equation. How this equation is coming? Suppose you have a transfer function of Cs by Rs, or you can say output divided by input. Okay. Then what I did, let's say it gives me a constant 5 divided by s square plus 25. Okay, this is my closed loop transfer function, and from the closed loop transfer function what I did, whatever the denominator term is there, I make it equal to 0. This is called the characteristic equation. Okay, characteristic equation CE. So suppose I'm giving you have a planned transfer function, you find out the transfer function and you got the characteristic equation. Now tell me, by looking at this characteristic equation, I have few questions to you. First question, whether the system is stable or not. Okay, and which type of stable is there, whether it is stable or it is marginally stable or it is unstable. If it is stable, then it is fine. If it is marginally stable, then what is the frequency of oscillation? If it is unstable also, then you can say it is unstable system. Can anybody tell me by looking at this question? Okay, don't give me any answer. Okay, let me solve another question for you. A general question I just want to solve. Let me give a general question. Let's say ASQ, I'm just giving ASQ, BS square, the third order system I'm taking, whose characteristic equation is given by this equation. asq plus b a square plus cs plus d equal to 0. Okay, you have gone through the lectures, I hope. So you have a small idea about how we are going to solve the RH criterion. Okay, so what is the highest order in this equation? Third order system. So what you do, you make a RH criterion table. So write down the highest power coefficient SQ and the next power S square. Okay, so SQ is given what are the odd powers are there. Okay, I'm just using a different color for the odd terms. These are the odd powers. Okay, SQ is the odd power. CS S to the power 1 is there, so this is an odd power. And for even I am using a different color. Let me use this color. Okay, this is a even and this is an even. Okay, these are the even powers and these are the odd powers. So whatever the even power coefficient, you have to write in this SQ line, and the odd power coefficient you have to write in the SQ line. So what is the first coefficient? ASQ, so I am writing here A. Similarly, what is the another odd type version? This coefficient of S is C. Okay, then S square, what are the coefficient of S square is B. And what is the another coefficient of even power? Here D means D into S to the power 0 is D. That's why here this 0 is even terms. Okay, that's why I'm writing here D. Okay, now what you do, you have to find out the remaining power of S. Let's say I want to find out what is the coefficient of S to the power 1. So what you do, according to RS criterion, what you do, you have to multiply this diagonally BC. Then you have to also multiply this A into D minus A into D, AD, divided by the previous S square coefficient. Here is B, so here is B. This is the uh, term for the S1. If you find out any other coefficient is possible for, no, I don't think so. Okay, next, what is the coefficient of S to the power? S is over. Once S is over, uh, then what you do, then tell me how to find out the stability of the system. What is the definition using RS criterion? That in the first column, what is the coefficient is there? All the coefficients should be positive. Okay. So what is the first column element of SQ? A. A should be greater than or equal to 0. This term should be greater than or equal to 0. This is according to the definition of RS criterion. I am not saying. Okay. Then similarly, B should be greater than or equal to 0. Another term is BC minus AD divided by B. This should be greater than or equal to 0. This implies that your BC should be greater than or equal to AD. Okay. So these are the three things you have to remember, that the coefficient of A has to be greater than 0, B has to be greater than 0, means all the coefficient has to be positive first instance, and second thing is that BC should be greater than or equal to AD. In the last class, I told you that to find out the stability of any third order system, what is the shortcut? I told you that inner product should be greater than or equal to the outer product. What is the inner product here in this equation? B into C. The outer product is A into D. So this inner product should be greater than or equal to outer product. I have derived from this equation, from this generalization, you can say that I solve a third order equation using RS criterion. Whatever the conclusion, I just make a intuitive formula that the if the inner product should be greater than or equal to outer product, then the system is stable, provided that A has to be greater than 0 and B has to be greater than or equal to 0. Okay. So if this you understand, okay, then just I'm giving a questions to you. Just please solve this. Okay. I'm just giving an equation SQ. Let's say 10s square plus 5s plus 50 equal to 0. What should be the answer? Whether it is stable or unstable or marginally stable? You can see clearly that again you same apply the RH criterion. You see all the coefficients are positive. Yes, the coefficients are all positive. Then you find out the inner product is 50 and the outer product is also 50. So 50 equal to 50, so the system is marginally stable. Okay. So how can you derive from the previous slide how this condition will be arrived? what is the condition of marginal stability in RH criterion? The marginal stability is that if one of this, okay, if one of this coefficient, let's say s to the power 1 equal to 0, if I equate BC minus AD not greater than equal to 0, if it is equal to 0, it means this term is now becomes 0, okay. In that case, what will happen? Then the system is going to be marginally stable, and whatever this on the above, what is there? S square, okay. So if you write the equation of this line, this will be bs square plus d equal to 0. Then this will be called the another powerful equation that will give you the damped frequency of oscillation, okay. This is called the auxiliary equation, okay. So how can I arrive this equation? If you make it equal to 0, BC equal to 80, if BC equal to 80 means the system is marginally stable. I told you that whenever the system is marginally stable, it has to oscillate at a constant frequency of oscillation. Now, which term will give the constant frequency of oscillation? Whatever the term is above, a square terms, okay, and make it equal to 0, bs square plus d equal to 0. This is called the auxiliary equation, okay. From this auxiliary equation, you have to find out the s value, and from the s value you have to find out the omega value, and that omega will gives the corresponding damped frequency of oscillation, okay. But come to here, okay. So this is the third order system I am directly giving to you. Then by looking at this question, suppose this question will be appears to me in the examination, I can see that the inner product equal to the outer product, the system is marginally stable, I can define in one line. Then if that question will ask me find out the frequency of oscillation, why? Because it is a marginally stable system. Then at what frequency the system will oscillate, how to find out? By looking at the question, what you do, you have to make the even terms equal to 0, okay. Let's make the even terms equal to 0. What are the even terms? 10s square plus 50 equal to 0. So s square plus 5 equal to 0, s equal to plus minus j root 5, okay. It means there are two poles which is at this position, one is j root 5, another at minus j root 5. When the system having two poles and these are conjugate, complex conjugate are lies in the left hand side of s plane, then you can see that this j omega d is the damped frequency of oscillation, is now this will be root 5, okay. So the frequency of oscillation is now root 5 radian per second, okay. You understand this question? If you understand this question, then come back to my previous first question. So what, tell me, s square plus 25 equal to 0 is a stable system or marginally stable system or unstable system? See, what is the general equation? If you compare with this line, as cube plus bs square plus cs plus d, you can clearly see that bs square, okay, b equal to 1, okay, but cs, coefficient of s, c equal to 0, okay. One coefficient is 0, it means the system is marginally stable. If the system is marginally stable, then what is the damped frequency of oscillation? Just find out omega from this equation. S square plus 25 equal to 0. So S equal to plus minus J 5. So the damped frequency of oscillation is, okay, what is the damped frequency of oscillation? S equal to plus minus J 5. So omega equal to 5. So answer is 5 radian per second. If you clearly understand this, if in a doubt, then ask me. I'll again clarify, okay. Did you understand this part? Okay, let us move little bit complex questions, okay. Let me give one questions to you. I'll just move to another type of questions. Let me go to s fourth, 2s cube plus 3s square plus 4s plus 5 equal to 0. Then tell me how to solve this question for system stability. This is the characteristic equation. Okay, it means from cs by rs, okay, something gs divided by 1 plus gs. Okay, you make this 1 plus gs equal to 0, or you get this equation, whatever the equation I have given to you. Then tell me whether the system is stable, unstable, marginal stable, or not stable. So how to do that? You just apply rs criterion is the best way. So write down here s fourth. Then what are the other coefficients are there? S fourth, I am writing here. S fourth is the even term. So here the even terms are 1. Another here is 3. Another is 5. Similarly, SQ you write down. SQ is 2. Another is 4. Okay. And remaining is nothing is there. Just write down 0 here. Then what do? You find out the coefficient of S square. I told you how to find out. So what do? You just do 1 into 4, 4 minus 6 divided by 2. Okay, you understand my question? See, look at, if you're not understanding, let's see here how I did it. You write b into c minus a into d divided by b. Okay, so what you do here, first you multiply 2 into 3. 2 into 3 is 6 minus 1 into 4 is 4 divided by 2. Okay, so let me solve it. 6 minus 4 by 2 is 2. So I am writing down directly the answer. Here this coefficient is 2. Then always remember, don't, whatever the power of S4, this 5, I just want to use a red color. This is just shortcut for yourself. You can see whatever the power of here S4, even terms, last term, it will be just translated to here. Okay, this 5 will become here, and this 5 is again come here. Okay, so what is that coefficient? Here the next term is s to the power 1. What is the next even term? S to the power 0. So this 5 will become here. Directly you can say this term will be 5. If you calculate also, it will give you 5. So directly whatever this term, it will be translated like this. Okay. Now tell me what is the coefficient of s to the power 1. So s to the power 1 is 2 into 4 is 8 minus how much? 6 minus 4. 6 minus 4 is how much? 2 divided by 2 is 1. This term is 1. I'm sorry. But this 5 will be carried forward like this. Now you tell me what is the next term? 1 into 4. This is 2 into 5. So 4 minus 10 by 1. 4 minus 10 is 6 minus 6 divided by 1. This will be minus 6. And this term will be calculated. This is 5 into 0. This is 4 into 0. So this will be 0. So this is the RH criterion. Immediately you can see that. Okay. So how many sign changes here in the first column? How many sign changes you have to see? Remember that in RH criterion, number of sign changes in the first column, number of sign changes in the first column gives the number of right hand side pole of the closed loop transfer function. So how many sign changes in the first column? You can clearly see that 1 to minus 6 there is one sign change, positive to negative. Again 6 to 5 another sign change is negative to positive. So there are two sign changes. If there are two sign changes, we can directly say that there are two poles of this closed loop transfer function lies in the right half plane. Okay, the right hand side of the S plane. Okay, suppose in this question I will ask you to find out How many poles are located in the left hand side? What is the answer? And how many poles are located on the right hand side? What is the answer? See, there are two poles on the left right hand side because you can see there are two sign changes. Let me assume that there are two poles on the right hand side. But how many poles would be on the left hand side? You can see out of 4 poles, 2 poles are on the right hand side. So 2 poles will be on the left hand side. Okay. So this will be the pole 0 location. So the system is stable or not? It is a non-stable system because the poles are exist on the right hand side. Let me go to the next question. If it's in doubt, then tell me. Okay. So based on the poles and 0 location, you can find out the system stable or not. Okay, this is the homework for you. You can see one right hand side pole, the system is not stable. Okay, 2 repeated poles on the left hand side, the system will be stable. This is also a stable system. All are stable system except the first one. It's a not stable system.
So the third diagram is marginally stable.
How can we say marginally stable?
It doesn't lie on the axis. No?
I'll come to your questions. Okay, marginally stable means the pole should be high lie on the imaginary axis and should be complex conjugate. Okay, not on the left hand side.
Okay, sir.
Okay, I'll come to some questions based on that. You don't confuse. Okay, try to understand what I'm saying. I'll go to more deeper questions for you. Okay, let's see. Let's solve this question. If you solve this question, I think some part you have to understand. A system having open loop transfer function is there. What is the system is stable or not? Directly from this open loop transfer function, I am writing the characteristic equation. I told you how to write it. Whatever in the denominator, okay, you write down here 5s³ plus s square plus 2s as it is a unity feedback system is given. So whatever this one you add in the denominator here, right, like that, and this will be the characteristic equation. Okay, once you find out the characteristic equation, then what you do, you have to make a very quickly you have to make a array criterion, because see, for third order system there is no problem, because the third order system, you know that you have to find out inner product greater than equal to outer product. You check all the condition of shortcuts are there. You can easily look, and suppose in this question if I remove this 2s fourth, then can easily you can say that here the inner product is here, you can say 1 into 2 and the outer product is 5 into 1. So inner product is less than the outer product, the system is unstable. But the question has does not say like that. It has adding a uh, fourth order system having 2s fourth is there. Okay, now for the fourth order system, you have to buy hook and cook. You have to go for the RH criterion. Immediately, just quickly you can write down on a small portion in the paper. Write down here s fourth, s³. Okay, write down the coefficient here 2. The even terms you write down first. Okay, 2, 1, and here also s to the power 0 is there. So 1, 2, 1, 1. Then again, what is the odd powers? s³. 5 is there, 2 is there, and nothing is there, so 0. Write down quickly what is the s square. So this multiply 5 into 1 is 5 minus 4. 5 minus 4 is 1. So 1 by 5. This term is 1 by 5. I told you don't calculate this term. This term will be carried forward here directly. So this 1 is coming. These diagonal terms will become like that. Okay, it will come. Okay. So after finding out this one, then you have to find out what is s. S how much? You again apply 1 minus 1 by 5 into 2. This is 2 by 5. 2 by 5 minus 5 into 1 is 5 divided by 1 by 5. You solve this one. But remember, whenever you're calculating RH criterion, exact value I don't want. Remember, if one person, if you are very smart in the examination, then one person what will do? He will calculate the exact value. What is this value x? But if a person is very smart, he doesn't care about the value. He will just check the sign whether it is positive or negative, because that only decides your system stable or not. Okay, I don't care about the exact value. I just need the sign of this term. So 2 by 5 is 0 0.4. 0 0.4 minus 5, this is a negative term. Just I am writing here negative. This term s is negative. Okay, then what is the s to the power 0? S to the power 0 is 1. By default this 1 will be landed here. Okay, so remember that this s to the power, all the even powers, the diagonal terms will become like this. Okay, then you see in this equation, in the first column, how many sign changes are there? 1 by 5 to negative, positive to negative, one sign change. Again from negative to positive, another sign change. So there are two sign changes are there. If two sign changes means two poles are lies on the right hand side of the system, and the system is unstable. Okay, you can quickly say the answer is unstable. You understand how I solve it? And remember, those people who are thinking that how this one is calculated here, you can find out, okay, by yourself. Apply this RH criterion and you will definitely get this value 1 and 1. Okay, so the two sign changes on the first column, the answer is unstable. If I tell you to find out the exact pole location, then how to do? First write down there are two poles on the right hand side. I don't know how these two poles will be on the right hand side. Okay, they, someone can draw the diagram like this, someone also can draw the diagrams like this. Okay, I don't care about the, I know that there are two poles on the right hand side. Out of four poles, two poles are on the right hand side. It might be two poles will be on the left hand side. Okay, okay, because I cannot see that one of the coefficient is 0 on the first column, so I cannot conclude that the system is marginal stable. If the system is not marginal stable, means there is no poles on the imaginary axis. That's why definitely the two poles will be lies on the left hand side. Okay, so like that you can analyze. So so suppose for this question, if I has given you four figures and given the pole location, then you can easily figure out what is the correct answer. Okay, is the question is give some idea, or you have a doubt, then ask me.
No doubt, sir.
Okay, let me go to another type of question. This is another type. Okay, what is another type? Let me give the question to you, and let me write s4. Suppose the characteristic question will be like this: 2s cube plus 2s square plus 4s plus 8 equal to 0. Then tell me how to solve this question.
Form RH criteria.
Do that. S4, to write down S4 S cube. Write down the coefficient of all the even powers first. Okay, these are the even row. This is the odd row. Okay, so even row is S4 1, then 2. This is 8. Then another one 2, 4, and 2 and 4. There are two terms are there. Another term is 0. You can write down. Next, find out the what is the next coefficient, S square. Okay, S square, how to find out? So 2 into 2 is 4, 4 minus 4 is 0. So I don't require anything, just to, this is a 0 terms. Okay, next this 8 has to be come here like diagonally. Okay, then what is the coefficient of s to the power 1? Whenever one column or one element is 0, okay, then the people will start confused here. Okay, let me how they will confuse, I am asking. Let me solve in this question in two methods. Okay, how the people will solve this question, let me see. Suppose you get a 0 value here, then what do you do? Next time you find out s to the power 1, you just check the sign whether it is positive or negative. So here what is happen? 8 into 2, 8 into 2 is 16, or okay, 0 into 4 first. 0 into 4 is 4, 0 into 4 is 0, 0 minus 16 by 0. So 0 minus 16 by 0. Here the people start confusing. This value should be infinity. Here the value is infinity is coming. Now they then what they will do here? S to the power. What is the power of s to the power 0? They know the shortcut that this 8 will come here. Okay. Can you now confirm? Can you confirm this from the analysis that whether the system is stable or not? because you don't know the value of infinity. Okay, this is an undefined term. So this answer, if suppose you are thinking that if you assume that by yourself, this is positive infinity is coming. Oh, it's positive infinity. So there is no sign changes in the first column. So the system is stable. You have to put the system stable tick mark and come back from the examination. Okay, but let me see here. What is the answer? Okay, so remember that whenever you are encountering a zero in the first column, immediately stop there. Okay, let me, I am actually, let's not erase it. Go back. Okay, so let me erase. Okay, no problem. You understand what I told? Okay, so now let's make calculate in my way. Okay, not in my way. This is the book method. Okay, you just see. So this element you encountered a zero. Whenever you encounter a zero in the RH criterion, assume that zero is a positive term, very small value g. Okay, assume that this is epsilon naught. Okay, you assume that this is a very small value. Take that value as epsilon naught. Epsilon naught is a very small value. I'm writing here. Epsilon naught is a small positive value. You assume. Okay, now you solve the question. You assume that there is a very small positive term and then you find out the next term. You know that this 8 will become here. This 8 will be appears here. Then find out the coefficient of s to the power 1. S to the power 1 is how much? This will be 4 zeta or 4 epsilon naught. 4 into epsilon naught minus 16 divided by epsilon naught. Okay, but you know that epsilon naught is a very small positive number. Then what you do? You take the limit of that. Limit epsilon very small number, let's assume that this is very close to 0, then solve this limit. Okay, 4 epsilon naught minus 16 divided by epsilon, solve this equation. So 4 epsilon divided by epsilon minus 16 divided by epsilon naught, so epsilon get cancelled. 4 minus limit epsilon naught, you have to put 0. Okay, then 4 minus, if you put here epsilon naught equal to 0, you'll get infinity. Okay, so 4 minus infinity is minus infinity. Okay, from any positive number, if we subtract infinity, it will give a negative number. Okay, so it means if you find out this value exactly, then this is giving you a negative number. This is a negative number. Okay, so if it is a negative number, you know that this 8 will be again come here. If you calculate, it will get 8 only. Okay, so now you can see on the first column how many sign changes are there. So from this epsilon is a positive number to negative, so there is one sign change. Here also negative to positive, another sign change. So there are two sign change. So the system is unstable. Okay, you got my point?
Yes, sir.
Okay, good. Okay, next actually let me go to another type of question. So in this question, I just will ask you like this. So question will be like this: s to the power 5, s to the power 4, 3 sq plus 2s plus 2 equal to 0. So in this question, let's say it is a gate examination, you are appearing the gate examinations or any competitive examination. Then there are four diagrams in front of you, the poll locations. Okay, there are various poll locations are there. Okay, I don't know what are the poll locations, but you assume that there are three options, and there are there are five poles in the characteristic equation, and the five poles are arranged in this S plane. Okay, so you have to choose one correct answer. And how you solve this question? You have to immediately apply RH criterion, because you know that you have to find out that how many Poles are lies on the left hand side, how many poles are lies on the right hand side. Let me quickly do RH criterion for this. S to the power 5, S to the power 4, SQ, S2, S to the power 1, okay, and S to the power 0. Okay, these are the terms we need to find out. So first write down what is there. S to the power 5 coefficient are there. This will be 1, then again this will be 3, okay, here again this will be 2, okay. Next 1, 3, 2, S4 is how much? Here is 1, and even terms here is 2, 1, 2, and nothing is there, so 1, 2. One term I'm missing here, 1 second. 3SQ plus 3S square plus 2S plus 2. It is given like that. Okay. Now you find out the coefficient. Here is 1, here is 1, 3, and 2, 1, 3, 2. Here is 1, again 3, 2, 1, 3, 2. Same. Okay. So 1, 3, 2 and 1, 3, 2 you got. When you can see that the two rows are same, then by default if you find out this column, then by default all the elements will be 0. Okay, so you are experiencing that one row is 0. Okay, when you are experiencing one row is 0, okay, then what? Okay, then how to solve this question? Remember that in RH criterion, when one row of 0 is occur, the system is marginally stable. Okay, no, it is the starting point. The marginal stable, it can be unstable. Okay, I don't want to give a marginal stable definition here. I am saying that if one row, listen this line everyone carefully. If one row is 0, okay, then above that, how many poles are there? The power of the coefficient is S4th. Okay, it means 4 poles. I am just writing 4 poles are symmetrical about origin. So definition I gave you. If one row of 0 occurs, then which row is 0 here? The S3 row is 0. So above that, the fourth row, S4th, it means 4 number of poles are symmetrical about origin. Remember this line. When one row of 0 will occur, then the poles will be symmetrical about origin. Don't think about marginal stable. Just remember that the poles are symmetrical about origin. So whenever you encounter a row of 0, then you cannot solve the question further now, because you already find out a one row of 0. Then if you do, then if you find out the arrest return further, you will get an infinity term. So you cannot proceed. So what you do here, you go to the even power terms. What are the even power terms here? S4. Another term is 3s square. Another term is 2. 2 means 2 to s to the power 0 is there. Okay, like that. You understand? S to the power 0 is 1. So what you do, you multiply the power and coefficient of these terms, even terms. So what is the power here? The power here is 4 and the coefficient here is 1. So multiply this, 4 into 1, 4. So 4 into 1 is 4, means you have, in place of this 0, you write down 4. I am writing in the bracket 4. Okay. So in place of this 0, you write down the power into coefficient. Again here, 3 into 2, this 2, 3 into 2 is 6. In place of this, you have to write down 6. Again here, 2 into 0 is 0. So here this coefficient is 0, you write down 0. Now assuming that this 0 are not there, this will be now 4, 6 and 0, and solve this question further. So how can you find out h to the power 1 s square? This term I want to find out. So again apply RH criterion. 4 into 3 is 12. 12 in minus 6. 12 minus 6 is 6. 6 by 4. is 3 by 2. And you know that this 2 will be carried forward because this is an even term. It will come here. Okay, and these two also will go to here. This will be diagonally to carry forward. Okay, this. Next, you find out h to the power 1. H to the power 1, you find out this is 3 by 2 into 6, 4 into 2 divided by 3 by 2. So this will be 2 by 3. So you got all the elements of this column now. You understand how I calculated? First, if you don't understand, then ask me. If you understand, it's good. How I calculated the coefficients. Is it okay?
Sir, can you explain again in the 4 and 6?
Okay. So what I did here, whenever you encounter a row of 0, okay, so you have to see that which row you are encountering a 0. You are encountering h to the power 3 at 0. Then what you go, you see that whenever one row of 0 is there, you imagine that whatever above is there, h to the power 4. It means 4 poles are symmetrical about origin. Then whenever you encounter a 0, you cannot solve further, because if you solve this, then what will happen? 0 into 3 minus 1 into 0 divided by 0. So it will give me an infinity value. Okay, it will be infinity. So I cannot solve this. Then what you do? In place of 0, I have to write something. So what you have to write to something? That's something I told, that you go to this s fourth. S fourth means here s fourth, okay, and here 3s square. This is 3s square, na. This is s fourth, na. This is 2s to the power 0, na. So you multiply the power and the coefficient. 4 into 1. You write in place of this 0, you can write 4. In place of this 0, you can write 3 into 2, 6. Power into coefficient. Okay. Here 2 into 0 is 0. Okay. Now these 0 are not in the picture, but it is in your mind that I encountered one row of 0. It means 4 poles are symmetrical about the origin. That point you have to remember from the mind, and you replace this 0 by 4, 6 and 0 and solve the question. Okay. Now this 0 I am removing, and now you solve this question. You will get this coefficient will be 3 by 2. Then I told you that the whatever the even power third term here, this term will be translated to the second term of h square. Then again it will translate it to the first term of h to the power 0. Then you again solve. Once you know 3 by 2, 2 and 4, 6, you solve h to the power 1 coefficient. This will be 2 by 3. Okay. Once you got all these values, okay, once you got all these values, you understand now how to calculate.
Ah, yes, sir.
Once you understand, then I ask you that draw the pole 0 locations. First, you have to check on the first column how many number of sign changes. Tell me. On the first column is the column 1, C1, column 2, column 3. How many sign changes are there on the first column? No sign changes, right? All are positive.
Yes, sir.
If there is
Yes.
no sign changes, then how many poles are there on the right hand side? No, 0 poles are
0
there.
poles.
Okay, so here on the right hand side, no poles are there. It means out of the 5 poles, all the 5 poles should be aligned in the left hand side. Okay,
Yes, sir.
now out of that 5 poles, 4 poles are symmetrical about origin. Why? Because you encountered one row of 0, right?
Yes.
Now, how to draw 4 poles are symmetrical about origin? Symmetrical about origin. 4 poles. Can I draw like that? It will be symmetrical about origin. Origin is this point, man. Is it symmetrical about origin?
It's not symmetrical, sir, but you have to draw here the
Yeah.
straight line.
No, no, it is not symmetrical. Okay, forget about this. This is not the option. So let me give a first option to you in the question. So there are 4 poles location like that. This is option number A. Is the option number A is correct?
No, sir.
No. So forget about option number. Nay, 4 poles you have to make symmetrical about origin, but no poles are on the right hand side. If one pole is on the left hand side, another pole exactly on the right hand side, then these are symmetrical about origin. So I can, okay, it can be possible. But here in the question, I am not seeing any poles on the right hand side. That's why all the poles should be lie on the left hand side or on the imaginary axis, right?
Yes, sir.
So can I make the four poles symmetrical about origin by placing it on the imaginary axis, right?
Ah, okay.
So now it is symmetrical about origin, right?
But it shows in right hand side, no, sir. For
No, no, I am just placing all these poles on the same location, map.
ah, okay, sir. Okay, sir.
Okay, these are on the same location. Okay,
Ah,
so now it can be one case like that, or not on the same location. You can say, but you can say suppose one pole at here, another pole is here, another pole is here, and here. They are symmetrical, right?
yes, sir.
Now it is one of the possibility. It means all the now we can say that to make my four poles symmetrical, I have to only option is that you have to place on the imaginary axis,
Mm.
because you cannot place on the left and right because there is no right hand side pole. So you cannot place any poles on the left hand side to make it symmetrical. So there is
Okay,
only
sir.
one option is left, that all the four should be aligned on the imaginary axis, right? So out of the five poles, four poles gone and one remaining poles are there. So you have to place by default on the left hand side. Why? Because there is no poles on the right
Sign
hand side.
changes.
Because there is no poles on the right hand side. That's why if this option is there in the question, they can tick it. Okay.
Okay, sir.
You got how I saw this question?
Yes, sir.
Okay. If you understand this one, let me give another question. Okay. I'm not doing the RH criterion. I'm understanding that you have already done the RH criterion and find out the first. Let me write the question. You have already done the RH criterion by yourself and you have to find out the coefficient. Let me give a seventh order equation. S6, S5, S4, S3, S2, S1, S to the power 0. I am just writing the first column element. Okay. You have to tell me the pole location. Let me write down the first. This sign is negative. This sign is positive because I have only considered about, I am only bothering about the sign changes. And this row of is a 0. Okay. S4 is positive. S3 is positive. S square is positive. This will be negative. This will be positive. Now you have to draw the pole 0 location of this question. Tell me. First point you have to identify. First, from this question, what are the understanding? First, you have to see that there is one row of 0. Whenever one row of 0 is there, how many poles will be now symmetrical about origin?
Six poles are symmetrical.
Write down here the first conclusion. 6 poles symmetrical about origin. This is the first observation. The second observation. Now, whenever a row of 0 is coming, the question is now divided into two parts. You have to look above one case, you have to look bottom one case. Now you see, out of these 6 poles, okay, 6 poles are symmetrical about origin. Now you see that below the 0 line, how many sign changes? One sign change, another sign change. So two sign change
Two
below,
signs.
two sign change below the 0 line, and here above the 0 line there is only one sign change. One sign change. Here two sign change below the 0 line. Below the 0 row. I'm writing like that to understand. One sign change above the 0 row. Now you remember that you have to place these 6 poles symmetrical about origin. But one line you understand that whenever a row of 0 occurs, you see below there are how many sign changes? Two sign changes. It means there are two poles which are right, because two sign changes means two poles lie on the right hand side, right? How many number of poles are lies on the right hand, means how many number of sign changes, that many poles are on the right hand side. But I am now dividing this question into two sections to understand exact pole location. So remember that below the zero line there are two sign changes. First, you place that 2 0 on the right hand side. Okay, I am just placing this 2 0 on the right hand side. Now remember that out of these 6 poles which are symmetrical about origin, these two sign changes what you did below have symmetrical poles should be lies on the left hand side. Okay, it means out of these 6 poles, it has a symmetrical point somewhere here. You have to place it first. You have this pole has a symmetrical point somewhere here. Let it place it first. Okay. Now out of these 6 poles, 4 poles are now symmetrical. Again 2 poles are there. But remember, there are only one sign changes above the 0 row. But remember, for this above line, there will be no symmetrical poles. It means let me add that pole first above the 0 line, because there are 3 sign changes means 3 poles should be on the left hand side. Let me add this pole, the third pole, which is also on the right hand side. Sorry. So 3 sign changes, it means 3 poles on the right hand side. But how many number of poles, how many number of sign changes below the 0 line that has a symmetrical pole, and how many number of sign changes above the 0 line that doesn't have a symmetrical pole. It means this black pole doesn't have a symmetrical pole on the left hand side. That doesn't matter. I don't care about that. So it means now I have placed 5 poles. Okay, but out of 5 poles, 4 poles are symmetrical about origin, but I have to make 6 poles symmetrical about origin. So by default, you don't have choice. You have to place these 2 poles on the imaginary axis to make 6 poles symmetrical. You understand this question?
Sir, could you explain again, sir? Only that.
Okay,
In,
this is a very important question. If you understand, then I think your whole means RH criterion total typical inside depth knowledge you got it. Okay. So first remember the first line in your paper, that first of all if there is a 0 row occur, okay, then above that 0 row the sixth S6, it means 6 poles are symmetrical origin. So this is point number 1 you write down. This is from the what I am observing from this equation. Once you know that there are 6 poles symmetrical about origin, you have to place these 6 poles symmetrically around the origin. But how to place? So to place, you have to first check that how many number of sign changes, total how many number of sign changes. There are 3 sign changes. 3 sign changes means you have to place 3 poles on the right hand side. Place 3 poles. I am writing. This is the first pole. This is the second pole, and this is the third pole. These are the 3 poles which are lies on the right hand side of the S plane. Now I am saying that you have to check below the 0 line how many sign changes. Below the 0 line there are 2 sign changes. It means these 2 sign changes below the 0 line means these red lines, second and third I am saying, these 2 poles have symmetrical poles about origin, because out of these 6 poles which are symmetrical about origin, then these 6 pole consider the bottom portion. Okay, it means you have to check that from that 0th line how many number of sign changes are in the below that 0 line. So how many sign changes? 2 sign changes. So it means these 2 poles which are lies on the right hand side have symmetrical poles should have to about the origin. If I place symmetrical about origin means for this pole, I don't want to change the color. For this pole, okay, there should be symmetrical points should be lies on the about origin. Okay, because I have 6 poles, I have to place symmetrical about origin. I got one pair, and for the because there are 2 sign changes, so place that another pole which also symmetrical about origin. So I place the second which is corresponding to fourth, and third which is corresponding to fifth. So how I already placed 5 poles. Out of 7 poles, I place 5 poles. But now I have to place another 2 poles because this is a 7th order system. So how to place the 2 poles? Can I place the 2 pole on the right hand side? No, because the total 3 poles should be lies on the right hand side according to the total number of sign changes. Total number of sign changes is 3. You already placed 3. So you cannot place the remaining 2 poles on the right hand side. You have to place the 2 poles on the left hand side. Okay. If I have option, I can place the 2 poles on the left hand side, but I have to make symmetrical above because only 4 poles are symmetrical about origin, but my first condition saying that there has to be 6 poles symmetrical about origin. If I place the 2 poles on the left hand side, is it symmetrical? Is 6 poles symmetrical about origin? It is not satisfying that condition. That's why I cannot place in the right hand side, I cannot place on the left hand side. I have to make 6 poles symmetrical. So by default I have to place on the imaginary axis. You understand?
Sir, if the poles in origin means it's symmetrical.
Yeah, it is symmetrical now. How much
Ah, okay,
distance on the
sir.
top, how much distance from the bottom. Okay.
Ah, okay.
You understand this
No,
question?
understand, sir. Sir, for the first pole, we can place it in the above the origin, no, sir.
Which pole?
That first pole, black color.
This one.
Ah, yeah,
First
sir.
pole.
Ah,
If I first where I need to place? Above the origin.
yeah.
I yeah. But if you place here above the origin, then it's a complex pole, right?
Ah, yes, sir.
So you have one complex pole doesn't exist. Complex poles are always exist in pair, right? So you cannot
Okay, sir.
place that, right? You have to place on the here, because if you
Ah,
have place here, ah, this is one possibility I'm saying. Another possibility I'm saying. Okay, you are right. You suppose I can draw the diagram like that. Let me see. So you are saying that this pole is placed here, this pole is placed here. It is possible. If it is
okay, sir.
possible, there is a complex conjugate pole here. This is a corresponding pole here. But another pole you have to place here. And for that, there will be no symmetrical poles, right?
Okay, sir.
And by default, other two poles will be placed here, right?
Ah,
The same thing, na? Two poles on the left hand side, two poles on the imaginary axis, three poles on the right hand side.
okay, sir.
You have to see which options are there in the exam. Okay.
This also correct, sir. For now, you draw.
Yeah, this is also correct. No problem. Because three poles on the right hand side, two poles on the left hand side, and six poles are symmetrical about origin.
Ah, okay, sir.
Okay. So that is also possible. So, okay. Now solve this question. Question number 4. A system has open loop transfer function. For what value of k, the closed loop system is stable? See, if I am in your place, after learning all these things, I can solve this question in 1 second. Okay, how to do that? Let me find out. He is asking about the closed loop system stability. So find out the closed loop system stability from this open loop transfer function I told you. S into s minus 1 into s plus 3 plus k into s plus 2 equal to 0. This is the characteristic equation directly in one line you can write down. You just add this here plus the same value we add here in the denominator because it is a unity feedback system. So characteristic equation you find out, just multiply quickly and tell me the answer. Okay, this will be s square minus s into s plus 3. What is this value? S square into s is s cube minus s square. Okay, this value is multiplied plus 3s square minus 3s. Okay, plus here k into s plus 2, add this value plus ks plus 2k equal to 0. Okay, just organize it little bit. S cube minus 3s square plus this will be plus 2s square. Okay, and this will be how much? K minus 3 into s plus 2k equal to 0. This is a third order system. You can apply inner product equal to outer product. What is the inner product? 2 into k minus 3. Okay, he's asking about to make the system stable. Okay, it should be inner product should be greater than equal to outer product. So outer product is 2. So 2k minus 6 greater than equal to 2. So 2k should be greater than equal to 8, k should be greater than equal to 4. If I did something where something wrong, just check it out, calculations. S into s minus 1.
Sir, could you explain again?
You just find out the characteristic question. That is fine for you. How to
Ah,
find
yes,
out?
sir. That's fine.
Can you just multiply? Na? Just I'm simplifying it. So s.
For in that fourth, after that, greater than or equal to 2,
Okay, okay.
that one, sir.
Let me solve here something I was missing out. Just let me see here. S square into s is s cube minus s square plus 3s square minus 3s plus ks plus 2k equal to 0. So s cube minus s square plus 3s square is plus 2s square, and here is k minus 3 into s. So up to this point, you understand? Up to this point number, let's say point 1.
Understand, sir.
Now what to do to find the system stability? This is a third order system. I told you that for third order system you find out the inner product. Okay, what is the inner product? 2 into k minus 3, right?
Ah, yes, sir.
Should be greater than equal to outer product. What is the outer product? 1 into 2k, right? Here the
Okay, sir.
coefficient is 1. Here this is 2k, right? This is the outer two. These two products. Okay, I told you now. This as cube plus bs square plus cs plus d equal to 0. In the system should be stability means bc should be greater than equal to ad. Okay, then solve it. 2k minus 6 should be greater than equal to 2k. Okay, so 2k 2k get cancelled, so k, you cannot find the value of k, so no such k is exist. Okay, the answer should be D, because you cannot find any value of k, because on both the side the k and k get cancelled. You understand? This is just mathematics. Okay, you have to solve an inequality question. Got my point?
Ah, yes, sir.
Let me give an questions. Let's say I'm writing g of s equal to k into s plus 1 divided by s cube plus bs square plus 3s plus 1. A unity feedback system is given. He's asking us to find out k and b such that the system oscillates at omega equal to 2 radian per second. Find out these two values. Tell me what is the answer. See, you cannot waste this much time. This is a question of maximum 30 seconds. See, this is an open loop transfer function g of s is given. Okay, to find out the closed loop system stability, I required only the closed loop system characteristic equation. This is the one line. Okay, characteristic equation, how to write? This is a unity feedback system. So write down first the denominator sq plus bs square plus 3s plus 1 and just add whatever in the numerator here. Ks plus k equal to 0. This is simple one line. You can write the characteristic equation. Then simplify it. Sq plus bs square plus coefficient of 3 plus k into s plus k plus 1 equal to 0. This is third order system, and he's saying that the system oscillates. Oscillation means at a constant frequency of oscillation means the system is marginally stable. You have to infer from this line. Then what you do? You have to inner product equal to outer product you do. What is the inner product? B into 3 plus k should be equal to outer product k plus 1 into 1. Solve this 3b plus k, 3b plus 3, 3b plus kb, okay, equal to k plus 1. Okay, there are two unknowns, and you know that when a system oscillates at omega equal to 2 radian per second, then what you need to do, you have to make in this characteristic equation number 1 the even terms, you make it equal to 0. So what are the even terms? Even terms is bs square plus k plus 1 equal to 0. Okay, from this equation you put s square equal to j omega square, it means minus omega square, right? Yes or no? S square equal to j omega j square equal to minus 1, so this will be omega square into b. What is j square? J omega square, right? Minus omega square. So you write down minus omega square. You understand how I write it? Then plus k plus 1 equal to 0. Okay. What is the value of omega? Omega is given 2 radian per second. So this will be minus 4b plus k plus 1 equal to 0. So k plus 1 I write equal to 4b. K plus 1 equal to 4b. So you write down here k plus 1 equal to 4b. So 3b plus kb equal to 4b. Okay. Now you find out kb equal to how much? B. So 4b minus 3b is b. Kb equal to 1. So here now you can find out k equal to 1. B get cancelled, right? Now you put k somewhere and find out b value. This is simply mathematics. If you don't have any doubt in this question, then we'll move forward.
Sir, when they give an oscillate omega is equal to 2, we have
Hmm.
to only choose the squared value, right, sir?
Yeah, means I told you that which square value, which you have to choose. This concept you have to understand that when it is oscillates means it is having a marginal stable. When a system having marginally stable, the poles has to be lies on the imaginary axis. How the
Okay.
poles, which poles are lies on the imaginary axis? This, let me see one, give an example. This thing is you have to clear, otherwise you'll confuse in the examinations. Okay, so
Okay,
first
sir.
tell me the let me give an s. Suppose a pole is s. Let's say s equal to, I'm just giving j omega value in the question is given 2, so let me write j2. Okay, then suppose another person is coming and he's writing sq. Sq means j2q. This will be how much? Is j minus j8. Okay, similarly let's say s square. a square means how? J2 square. Okay, this will be minus 4. Now tell me, from this observation, these are the odd powers. This is an odd power. This is also an odd power. You see the odd power. Odd power should be lies on where? Imaginary axis, right?
Yes, sir.
Even powers are lies on the real axis, right?
Ah,
So that now you come to the question. Odd powers are lies on the imaginary axis and even powers are lies on the real axis.
okay, sir.
So now I told you that the system oscillates. You have to, this is a marginal stable. The poles are located on the imaginary axis. So one question is given like this. Let's say SQ, S square, S, S4. Another term is, let me add S5, S4, SQ, S square, S. Something is given like this equal to 0. Let's say 5 equal to 0. Now you tell me, if this system is marginally stable, then the poles lie on the which axis? Imaginary axis. Yes or no? Marginally stable means the poles lie on the imaginary axis, right?
Yes,
It means which terms are exist? Odd parts are exist or even parts are exist?
even parts.
Arey yaar, you are now on the marginal axis. Your home is in the marginal axis. You are then marginal axis means you have odd parts are lies in the marginal axis. Odd coefficient. You see, now odd coefficient are lies in the
Ah,
marginal
okay,
axis.
sir. If there is an imaginary part, means it's a lie on odd.
Yeah. So you have to
Ah,
make the even terms 0, right?
yes, sir.
So I did the same thing. Now the last question.
Ah, now I understand, sir.
Yeah. Where is that slide here? Yeah. I make the
Ah,
even terms 0, na?
yes, sir.
Bs square plus k plus 1 equal to 0.
Zero. Ah,
To solve it, simple. Okay. To understand this better, then this question, can you look at the question and tell me whether can you able to solve this question? Just read and tell me. How many poles are there in the right half plane, left half plane on the geometric axis? It is very easy for you now. Yes or no? Just I told you lots of concept. Okay, how many poles are just lies in the left and right and geometric axis? Can you able to do? I actually,
sir, it's a
Yes, we
unity
have to find
feedback,
the
no?
roots of the characteristic equation.
sorry.
We have to find the roots of the characteristic equation.
Yeah, he just say just read the question, sir. For the closed loop transfer function, he's asking. So you have to find out the characteristic equation, right? So the system itself is given a closed loop system for the
Yes,
closed loop transfer function. So
yes.
equate the characteristic equation 0 and find out the RH criterion and apply. How many poles are lies on the left hand side, right hand side. See the negative, how many sign changes are there, all these things.
Sir, we have to only looks on the denominator.
Yeah,
Ah,
I have
okay.
to make the denominator equal to 0. See, directly you just from the, don't write the denominator, just write, draw the, uh, draw this. Okay, S5 is how much? 1 minus 2, sorry, 1, 3, 2. Okay, here is minus 2, here is minus 6, minus 4. Okay, one negative term is coming, you see. Next, find out SQ, how much? Multiply this, minus 2 into 3 is minus 6, minus 1 into minus 6 divided by minus 2. How much this value?
Zeros.
Minus 0. So you can see that these two, whatever the row 1 and row 2 are proportional, because this is 1 3 2, this is also minus 1 minus 3 minus 2. They are proportional, means you will get a one row of 0. Okay, once you get a one row of 0, then what you do, you must multiply the coefficient with, okay, so here 2s fourth is there, here minus 6s square is there, here s to the power 0 is there. So replace this, multiply the coefficient with the power. So minus 2 into 4 is minus 8, minus 6 into 2 is minus 12, minus 4 into 0 is 0. So now this 0 is replaced by minus 8, minus 12 and 0, and carry forward the remaining. Okay, and tell me how many poles are there. Okay, how many poles are there on the imaginary. You can see if one row of 0 is there, means your first conclusion is there. There are 4 poles symmetrical about the origin. This is my first conclusion. I'm looking at this 0 line. Then you find out how many sign changes are there on the first column. Okay, you just try this question by yourself and match with the options. Okay, this is my just question. Okay,
So there is one pole, sir.
okay, tell me what is the answer options.
There is a one pole on the right hand side, sir. Right hand side.
Okay, one pole, which option? This option is matching, sir.
Yes. Last answer.
Okay, but one thing, sir, see how many sign changes below the 0 line, can you tell me?
How many?
So number of sign changes below this 0 line, this line, this is the 0th line, huh? How many number of sign changes?
How many sign changes?
Yes, below this 0th line.
Two sign changes, no?
Two sign changes below the 0 line. If there are two sign changes below the 0 line, then there should be two poles lies on the right hand side half plane, huh? Then how can you say,
There,
sir, the option 1 is
there,
correct?
there are two poles lies in the.
Now what you told, sir, I am asking you that below this 0th line, whatever I'm screening in my screen, how many number of sign changes here from this coefficient to this coefficient, how many number of sign changes? Is there any number of sign changes or there is no sign changes?
Yes, sign changes, no, because there is a number. One pole is there, no, on the right hand side.
Sir, here above the 0 line there is one sign changes. You can see from positive to negative is
Yes, sir.
coming. Okay. So here I can say that one pole should be lies on the right hand side. But I don't know because I am not solving this question. But you have to check how many number of sign changes below this 0th line.
Sir, below the zeroth line, there is no sign changes, sir.
Okay, that's the point. Okay, if there is
It's all becoming negative, sir, but there is no positive sign changes
okay,
here.
good, right. All are negative means there is no sign changes. So there is only one sign changes above.
Above
So
the zero.
one point should be lies on the right hand side and four poles you have to make it symmetrical.
Because there is already 5 poles, 4
Yeah,
poles are symmetrical about origin, and 1 pole is right hand side.
right. Thank you. That's okay. The answer is option maybe 104. I don't know, but I'm just believing your statement. Okay. Okay. Next question. Let's come to this question. I'll just do this as a final question to solve it for today's session. Okay, so just tell me, in this characteristic equation, how many poles does the system have? Negative real part minus 1. So remember one thing, this is a question of relative stability. Okay, so what is relative stability? First, to understand that whenever any question is saying about relative stability, you first point keep in mind that okay, the system is stable. Okay, but how it is stable, that you need to find out. It means already the system is stable, but how? See, when the poles are very nearer to origin, very nearer to origin.
So
Okay,
there are three poles, sir, that have negative, that have real part minus one.
okay, sir, good. I'm just telling you that how to solve this question, sir. So it is a question of relative stability. Okay, relative stability means you have to first understand that the system is stable. It means whatever the characteristic equation is given, it is a stable system. You can clearly see that the inner product 4 into 3 is 12 greater than the outer product. So by looking at the question, you can say that the system is stable. But he is asking about not at about 0. He is not asking at a is equal to 0. He is asking at some point which is a is equal to minus 1. It means from a is equal to now the origin is shifted to minus 1, not at 0. Now he is asking about minus 1 point. Now the origin is shifted to minus 1. Now previously your origin about a is equal to 0, you are applying inner product equal to outer product, you say that the system is stable. But he is not asking the question like that. The question he is asking that you now shift your origin a is equal to 0 to a is equal to minus 1 line. Now the new origin a is equal to minus 1 line. Now you modified this equation. The equation is not now here sq plus 3s square plus 4s plus 2 equal to 0. This is about 0 line. But whenever it is shifted to minus 1 line, you have to put in place of s, you have to put s minus 1 cube plus 3, okay, 3 into s minus 1 square plus 4 into s minus 1 plus 2 equal to 0. Now you solve this question. Okay, this is again a third order equation. Then apply uh, your concept of RH criterion or inner product equal to outer product. Then you see that how many poles are now which is out on the right hand side of minus 1 line. If there are sir is saying that how many poles does the system have negative real part. Negative real part means about this. Now this characteristic equation, this is the final characteristic equation. This characteristic equation have all the poles lies in the negative half of minus 1. Okay, it means now the origin is shifted to minus 1. Now you solve this question and check whether the system is stable or not. Okay, if the system is stable means all the poles lies in the left hand of minus 1. Okay, you understand what is the concept of relative stability? Now your origin is now shifted to s equal to minus 1. Okay,
So one doubt is there, sir.
yeah.
How to find the signal is bounded, sir? Differential equation is suppose given.
And sorry, you don't write s equal to minus 1. You have to at s here, sorry, I just did a mistake here. I'm coming to a question, sir. Just I did a mistake. S equal to minus 1 given means s plus 1 equal to 0. It means everywhere in place of s you write down s plus 1. I'm sorry. Okay, now you solve this question and find out and the characteristic equation of this new axis, and you check the system is stable or not. Okay, and coming to your question, sir, how to take whether the system is bounded or not. What to do? Bounded system means, okay, your input is bounded means you have a constant amplitude. Okay, it means at t tends to infinity, if you put t tends to infinity, it gives finite value. Okay, it gives a definite value or finite value, you can say it gives a finite value. Like, let me give an example. U of t. U of t is a signal up to infinity, t tends to infinity. It gives always a amplitude of 1. If you integrate it, you'll get 1. From 1 to infinity, whatever the value, you'll get always 1. Okay. Okay, so this is a bounded, it gives a finite value. So any signal you integrate, it gives a finite value, that is a bounded system. Any other doubts? I have some other questions. Okay, I am just, okay, let me quickly solve this question. Find the system shown in figure, find the range of kpki, the system, this closed loop system is stable. Okay, for this question, what you need to do, you find out the characteristic equation of the closed loop system, closed loop transfer function. Then you check, apply inner product equal to outer product. Sorry, system is stable, you apply inner product greater than equal to outer product, or who are very the person who are very comfortable with RH criterion, they can apply RH criterion and find out the constant values what is given to you. Okay, so let me any other questions is there? Okay, this is a question number 10. He's saying that what is the relation between k and p, so that the closed loop system is stable. Again, you have to find out the closed loop characteristic equation, make again the inner product greater than equal to outer product to make the system stable, and find out the relation between k and p, because these two are unknowns. Okay, so I think I have 10 questions. I have to stop here because I have some work, I have to go. So thank you all, thank you so much all of you. Okay, if you have any doubt, we can discuss in the next class. But I have a meeting at 8:40, so I have to leave. Thank you so much all of you.
Sir, when this video will be uploaded?
I'll upload by tomorrow morning or day after tomorrow morning. Okay.
Okay, thank you, sir.
Okay, thank you. Have a nice good night all.
Good night, good night.
Thank you, sir.